Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
Today, we're diving into a piece of engineering that's pretty much invisible, but it's the secret sauce that lets everything from your 3D printer to those giant factory robots move with just impossible precision.
I mean, have you ever really stopped to think about it? How does a 3D printer lay down a perfectly straight layer? Or how can a factory robot hit the exact same spot thousands of times a day? What's the magic behind that flawless straight-line motion?
Well, the answer is this amazing and honestly kind of essential part called the linear bearing. Its whole job, its entire purpose, is to do one thing and do it perfectly. Guide something along a single straight line with just mind-blowing precision.
Okay, so let's pull back the curtain on these unseen movers. We're going to break down exactly how they pull off that perfect back and forth, super smooth motion.
So at its absolute core, a linear bearing is all about one thing, giving you free, super low friction movement in one direction. Think of it as the critical link, the go-between, connecting a moving part to the track it's supposed to follow.
But how do they actually do it? How do they get that silky smooth, low friction movement? Well, it turns out it all boils down to two big ideas.
And those two big ideas give us the two fundamental families of linear bearings. You've got your rolling element bearings on one side and your plane bearings on the other.
You know, the difference is actually pretty simple to wrap your head around. Rolling bearings, think of them like a skateboard. They use tiny balls or rollers to just glide along and slash friction. Plane bearings, on the other hand, are more like a block of ice sliding on a super smooth floor. They just rely on two low-friction surfaces sliding directly against each other.
And you can really see it here. On the left, you've got the complex guts of a rolling bearing, right? With all those little circuits of tiny balls doing their thing. And then on the right, a plane bearing. So much simpler. It's really just about the shape, the geometry of two surfaces sliding together.
Okay, so let's zoom in on the most common family for a bit, the rolling bearings. Because inside this category, engineers have to make a really critical choice that impacts literally everything from cost all the way to performance. And that choice is the shape of the track, or what we call the rail.
So if you're building a machine, how do you pick the right track? Well, it pretty much boils down to two main shapes, the round rail and the square rail, which is also called a profiled rail. And this table here, it really lays out the trade-offs perfectly. Look, square rails are the undisputed champs of performance. They have amazing load capacity and rigidity, and part of that is because you can preload them, basically tighten them down so there's zero wiggle room. And those ground raceways, that just means the tracks are super smooth and precise, giving you incredible accuracy. But here's the catch. You need a perfectly flat surface to mount them on. Round rails, though, they're way more forgiving, much easier to mount, and they don't mind getting a little dirty. And here's a huge reason why those round rails are so forgiving. The bearing can actually rotate a little bit around the shaft. So if your mounting surface isn't perfectly flat, no big deal, it just compensates for it. This whole self-aligning thing makes building the machine way cheaper and a whole lot easier.
Okay, now I want to talk about a truly game-changing idea in rolling bearing design. See, in the early days, the little balls inside the bearing only touched the track at a single tiny point. But then, somebody had a brilliant idea. And this quote right here, it just perfectly captures the massive impact. So here's what that's all about. Instead of having a round ball on a flat surface, which gives you that tiny point contact, designers started machining a curved groove into the track, one that perfectly hugs or conforms to the ball's shape. It sounds like a small change, right? But it means the load gets spread out over a much, much bigger area.
And what's the result of that? Well, the bottom line is this tiny little geometric tweak led to a 27-fold increase in the bearing's lifespan. Let that sink in. 27 times. I mean, for the industry, that is just a monumental leap. It means machines can run longer with way less maintenance. It means critical stuff becomes way more reliable. It's just a perfect example of how one small, clever design change can have a truly massive impact.
All right, so we've seen how precise and clever rolling bearings can be, but what about that other family? Let's not forget about them. It's time to check out the power of simplicity and take a look at plane bearings.
So when on earth would you choose the block of ice over the skateboard? Well, you do it when you have to handle absolutely huge static loads or when you need to soak up a lot of shock and vibration. You'd use them in really dirty, grimy environments, or, frankly, when cost and simplicity are the most important things. In all those cases, plane bearings aren't just an option, they're often the absolute best choice.
Okay, let's bring this all back to the real world.
how do all these technical details and trade-offs actually play out in the machines we see every day? Well, it all comes down to one thing: matching the right part to the right job.
Think about something like a 3D printer for your home, or maybe some basic lab equipment. For those, being affordable and easy to put together is way more important than having insane rigidity. And that's exactly why you'll almost always find round rail bearings in them. That self-aligning feature is just a perfect fit.
But now, picture the complete opposite, a giant CNC machine that's carving through a block of solid steel. In that situation, every tiny bit of movement, every micron of deflection totally matters. You need the absolute maximum rigidity and precision you can get. And that's where the square rail guide just shines. The incredible performance is worth the extra cost and the tricky installation, no question.
But wait, what if you need to do two things at once? What if you need to move in a straight line and transfer rotational force, what we call torque? Well, for that, there's a special kind of part called a ball spline. It has these grooves that stop it from rotating when you don't want it to, which makes it perfect for things like robotic arms that need to push, pull, and twist with total control.
So what's the big takeaway from all this? It's that there is no single best bearing. It's just not a thing. There's only the bearing that's the best fit for the job you're trying to do. You have to think about everything: cost, precision, how much weight it's holding, and the environment it's going to live in.
So, in the end, every single smooth, precise movement you see out there, it's the result of an engineer making these kinds of trade-offs. So the next time you see a machine in action, maybe you'll spot those invisible rails guiding its path. And it makes you wonder, right? What other amazing, unseen engineering will you notice next?
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.